Okay. So I think we should go on with module number 5 about the making decision here. Making decision, that means it's right. You learn that. You learn it in the module number 4. That basically for every program you have the 3 basic structure, right? And every program is a combination of 3 basic structure here. It is sequence, it is a decision, or it is looping, right? So you know that the sequence, that means everything happen in the order, right? From the first statement to the second statement and so on here. That is a sequence. And in the decision, you have the condition here to check, and if yes, you do something, and not yes, you do the other thing, right? So in this chapter, you learn about the selection structure, relation, comparison operator, and logic, or logic and not logic. Actually, you learn it in the module number 3 already, right? And also you learn about making a selection within range, and you can use when combining the and or you have the order priority also, and you learn about the case structure here. Right. So for the selection structure, right, you work with the Boolean expression. It can be only true or false. And you know that basically for computer, right, it works with the binary number 0 and 1. I can think about it. That 0, that means you have 4, and 1 you have the true here. Right? And every computer make decision based on true or false, or yes or no, or 1 or 0 here. And you can think that to make it simple, you can think 1 that means true, right? 1 that means true or yes, and 0 that means false or no here. And for the selection here, for 0 and 1 here, for Boolean expression here, it is in every selection structure. And you know that when you work selection structure, you have the condition here to check, right? If yes, you do something. If no, you do the other thing here. Make sense? Okay. So that is in the case of selection structure here, it can break it down into dual alternative, right? Or the selection structure here, it can provide an action for each of the 2 possible outcome here, right? So basically, that is a decision structure here. You can look into the slide here, right? You have a here condition here to check, and if you yes, you do something, and if you no, you do the other thing here. That's why they call dual. Dual, that means 2 branches, right? And if yes, you do something, and if no, you do the other thing here. Right. And also you can have the single alternative here, right? It's a single alternative here. So for this one, the action is provide for only 1 outcome. Outcome only. Think about this one. Right? You have the condition here to check. If yes, you do something, but no, you don't do anything here. Right? That is the case of the single alternative. So basically, in the selection structure, you can have the dual alternative, or you can have the single alternative here. So for this one here, right? So you think about in the program here. I think I don't want to work this one here, right? So basically, when you work with pseudocode here, whenever you work with selection, you have if, then, and else decision, right? So if then clause here, it holds the action or action that execute when the test condition in the decision is true. Right? So you see, if you check the condition here, if the condition true, you do something here after then, right? And else clause here execute only when the test condition in the decision is false. That's why they work with the if and else here, right? And so you know that whenever we work with any selection structure here, you have the condition here to check. Right? You have the condition here to check, and the condition it can be the relational comparison operator here. So what is the relational comparison operator? It can be equal or not, right? Greater than or not, less than or not, less than or equal or not, or greater than or equal or not, right? So they call it the relational comparison operator, right? Okay, so you have the 6 types support for by all modern programming language here. You check here, equal or not, right? So remember that if you want to check if the 2, if they are equal or not, you have to use the double equal sign, not the single equal sign, right? Because you see, if you put the single equal sign here, what does it mean? What does it mean? It's the assignment, right? That means you give the number 10 to the variable x here, right? And if you want to check if something equal or not, you have to use a double equal sign here, right? Think about if you go to part you put it here, 10 equal to number 20 or not, 20 or not, you have to 4 here, right? Okay. So you can go practice with the idle here in the sorry with the interactive mode here in the Python. I can go to the idle here. You click on Python here, and you can double check it with the command, right? So we think about we have 10 here, 20 here equal to number 10 or not? No, right? It gives you that no here, right? And 20 here greater than 10 or not? It gives you 2 here, and so on, right? And if you have the 20 here greater than or equal to number 10 or not, 2 here, right? So they are relational operator. So basically, it's the relational operator. You remember that you have the 6, right? You have the 6 type of relational operator. The first one, you check it equal or not. The second one, you check it greater than or not, less than or not, greater than or equal or not, right? Less than or equal or not, and not equal, right? So not equal here, right? So think about in the case not equal, you have to put the exclamation and the equal sign here. I think about in the case in the Python here, right? In the Python here, I check with the condition here. I check it here. 20 here, is that not equal to 10 or not? True, right? Because sure, 20 is not equal to number 10, right? So basically, in the any programming language, you have 6 types of relational operator: equal or not, greater than or not, less than or not, greater than or equal or not, and less than or equal or not, and not equal here, right? And in the case, sometimes in the case you work with the pseudocode here, if you want to check it's not equal or not, normally they put in the symbol here, right? But anyway, you can put the exclamation and equal here is that's the not equal. Okay, so you go with the relational comparison operator, right? You check it equal or not. You remember that you have to use a double equal sign. Greater than, less than, right? Greater than or equal, less than or equal, or not equal here. Right, so basically for the relational comparison, right, any decision can be made with only 3 types of comparison here: the equal, greater than, or less than, and you can combine them together, right? You can combine them together. I think about this one here, right? You have the program here, you got the customer edge, and you make the decision here, right? If anyone is greater than or equal, older than or equal 65, he has a discount of 10%, and if not, he have no discount here, right? So it's a program here. It's a program, right? Think about you got the customer edge here. Edge here. And you store it into the variable name customer edge here, right? So you make a decision here. If customer edge greater than or equal 65, then you have the discount here 10%. Else, that means not true, right? You have the discount 0 here. So basically, for these 2 programs here, for these 2 programs here, they are the same, right? You say they are the same. You see, the first one you check if the customer greater than or equal 65 or not. You got the discount number 10 here. Else, that means you have no discount. So you can think about you have the line here, right? Everything from 0 and 65 and more than 65 here, right? So whenever you have the greater than or equal 65, you have 10% here. And less than 65, you have 0% here, right? So basically, you can do it in the other way. This way or this way, it's the same, right? You see, if the customer edge less than 65, you have 0%. And else, you have the 10% here. So basically, the 2 programs here, they are the same, right? The 2 programs here, they are the same. So in the case of the relational operator also, right? So see, so this one here, you have the customer code, right? If the customer code is not number 1, you have discount here 25%, and if customer code it is number 1, you have 0.5%, right? So this one here actually not number 1, right? So remember that this one is not number 1, right? So if customer code is number 1, you have 25%. If not number 1 here, you have the 5%. Okay. So what does it mean for this one here? Actually, it's quite confusing here, right? For this one here, if not, right? If not here. So what is it? If I have the customer code number 1, so what do you think? Do I have the 25% or 50%? 50%, right? Because customer 1 here, you check here. No, right? That's why you have the 50%. Okay, now you know that whenever you do the selection, you have the condition here to check. Right? So think about in the case here, it's very simple. You check here, is customer age greater than 65 or not? That's a single condition only. Right? It's a single condition here. But sometimes you can use a compound condition. That means you have more than one condition. That's a compound condition here. So we can ask multiple questions before an outcome is determined here. And one of the compound condition here is the AND decision. And you know that the AND decision, right? It requires both of the two tests evaluate to choose, and then it choose here. I think about you learn about the truth table already, right? You have the two income for the AND here. For the AND logic, you have the two income, right? You have A and you have B here, and you have outcome, right? So see, for the truth table here, if you have the two variable, how many rows you need? 4, right? Because it's a logic here. 2 raised to the power 2. You have 4. You have a 4 row. So see the outcome here. If you have 0 and 0, you have 0. You have 0 and 1, you have 0. You have 1 and 0, you have 0, and you have 1 and 1 here. You have not 1, right? So basically, for the AND decision, the outcome is only true when both of the input true. In any other case, you have 0 here. You have a 4 here, right? Okay. So basically, in the case of the selection, you can use the compound condition here, and you can use with the AND decision and OR decision or NOT decision here, and so on. Think about this one here. I think about when I work with this one here. I want to work to this program here, right? So in this program here, I make decision here if someone is eligible to join army or not, right? So remember that he's only able to join the army when his age greater than or equal 18 and his weight here greater than or equal 140, right? So basically for this one here, right? When you work with the AND decision here, basically you work with the netted decision. You put one decision inside another one, right? You put one inside another one here. So think about this one here. You can think about this one here, right? In this program, I have two programs here. Program number 1 and program number 2 here. And you can see for the both program, they deliver the same output. And I make decision here. The one is only able to join army when he greater than 18 and his weight than more than or equal 140. Now, I'm asking you about this one. If I have someone is a 16 and he's 160 pound here, right? So what do you think? He's able to join it or not? No, right? And how about this guy? I have the 20 here and this one 160 here. Is he able to join? Yes, because the both decision here correct and correct here, right? And how about this one? I have the 30 here and I have one 30 here. Is he able to join? No, right? Because this one yes, but this one no here. And you know that for the AND decision, the output is only correct when both decision is true here, right? Okay. So now for this one, I work with the netted decision because basically when you work the AND here, when you work the AND logic here, that means you work with a netted decision. That means you put one decision inside the another one. Okay. So now we will look on this one here. You see, I raise a question here, right? If greater than 18 or not, right? If true, I go with this one, right? If true here, I go with this one, right? I go with this one. Sorry. Yeah. Right. So see, for this one here, Z is outer, right? You see, Z is the outer decision here. If L and if here, right? That is inner here. If L and if. I totally put the second condition here inside the first condition, right? So see, if greater than or equal 18, I do everything with here, right? I do everything with this one here. And again, I make decision here. If you weight greater than 140 or not, if yes, I do on this one, right? So basically, if you look on these two programs here, they deliver the same output. It only delivers the same output. And make decision here is that someone able to join army here only when he is greater than or equal 18 and he's older than or greater than or equal 18 and his weight is greater than or equal 140. They deliver the same output. But remember that the way the computer executes is not the same. Now think about this one here. Now think about this one. Think about I have many guys here. They want to join the army here, right? And you see, all of them they look very young. Even that they are the big guy. But many of them here, many of them they look very young. So see, if I see that many of them look very young here, so what is the first condition I should ask here? You think about this one. You think about this one here. If I see that many of them they are very young, I don't believe that they are greater than or equal 18 here. So what do you think? What is the first question I should check here? I can check for the age first. I can check for the weight first here. But what do you think? What's the option I should do it?
The age more efficient.
Yes, right. This one here more efficient here. Now why? You see what happened here? If age here less than 18, what happened? No way they can do with the army here, right? So basically for this one here, I can skip everything. I don't have to check the second condition anymore. Make sense? Because it's an decision here. You see, it is an decision. You know that the end decision here it's only true when both of them true. But any one of them is not correct for sure. I can skip the second one. Right? So see, if many one of them look very young here, right? If many one of them look very young here, I can raise the question here: are you older than or equal 18 or not? And if they say that I'm not, I do not have to check for the weight here anymore. Right? So that is the way computer execute for the AND logic here. So basically, in the case if you have the AND condition here, normally to make it more efficient, you have to check the condition that less likely to be true. Right? Less likely to be true. Right? So see, many of them here, I believe that they are very young. They have no way greater than or equal 18 here. I check this condition first. Right? I check the condition first and they no, I'm not greater than 18 here. So we know when they have net 18, I don't have to check this one anymore. Make sense? It's more efficient here when you work with the AND logic. And you see that something is less likely to be true, you check it first. Okay? So that's why in the case of the AND logic here, right? In the AND logic here, they tell you, right? They tell you here. In the AND decision here, the first you ask the question that less likely to be true first to make it more interesting, right? So the computer do not have to check the second condition here. Okay. So you can eliminate as many instances of the second decision as possible here, and you can speed up the processing time. Okay. So that is a case of the AND logic. So basically, you see, for both of the program here, number 1 and number 2, they deliver the same output, but it depends on the condition, right? So you see, if many of them they are young, you don't believe that they are greater than or equal 18 here, you check this condition first, right? You check the condition, or you can see that they are very skinny here. They are many guys that skinny here. You don't believe that they are greater than 140. In that case, you check the condition here. Are you greater than 140 or not? Many of them not, right? So you don't have to check the age. Okay. So basically, in this program here, right? In this program, you can work with in this program here. You can work this program with the pseudocode or with the Python here, right? So you guys can open the Python and do this one with the Python here, if you want. So in the case of Python, I just show you how to work with the if and else here. Right? Okay. So you open the Python. You open the new file, right? So think about this one here. You get, right? I think you raise this question first. You raise this program first, right? You make decision if the customer is greater than 65 or not. And now you print it out. You have the discount numbers 10% here. If not, you have discount number 0, right? So you open your Python. You write the program. You have to get. Guess customer age. Guess the customer age here. And now you make decision. If he greater than or equal 65, he have the 10%. If not, he has the 0% here. Okay. Now please open the Python, right? And do it with the Python here. Or you can work with the Visual Studio Code. It's up to you. So For me, I prefer working with the Visual Studio Code here, so I will open it with the Visual. Okay, so you know that when you work with the Visual Studio Code, right? You have to select the program here. I work with the Python. Make sure that you have to install the Python, right? So now for this one, right? You know that to make it practice here. Whenever you work with the Python, you put the header command, right? This program. Determine if customer get discount for 10% or not, based on his age, right? So you know that the command here is only helpful for the programmer. It's not for the computer, right? When the computer executed the header command, it will be it's ignore here, right? So now, in order to do that, you know that for this program, what is the input here? How many input for this one? Tell me for this program, how many input? Right? For this one here.
2.
This one. Yeah, user needs one input here, and the input here is a customer age.
Oh yeah.
Right? So, yes, so you know that in order to get it in the Python, you put it here, customer age here, right? You put it in the left, and you got it by the input function here, right? And the customer. Okay. Now, what else you have to do with this one? What else we have to do with this one? You know that in the Python, whenever you want to get input from user, you use the input function here, right? And what else you have to do with this one? I mentioned it already. That's this. Can you tell me the answer for this one? What else I have to correct for this one?
Make it a number.
Yes, you have to make it a number, right? And I mentioned that basically everything you got from input function is in string format, right? In string format here. But now you have to work with the number here, right? So basically you have to convert it. You have to convert this one into the number format, and you have two functions to convert it. What are they? You have two functions to convert it. What are they?
Filter.
Yeah, you have int, right? And you have a float here. Like that, int that means you convert it in the whole number. And integer, the float here, you convert it in the floating point number, right? So basically for the h here, you can work with the integer number, right? So you can put everything here. You can put everything inside the parentheses here, and you convert it into the int here, right? Int here, okay? So now you see, I got it, and now I can check with my condition here, right? So I check with condition here. In the Python, again, the syntax is if here, right? If you check here, customer age here, right? And greater than or equal 65 or not. After that, remember you have to put the column here. Right? You have to put the column here, right? And if greater than 5 here. Now you just print it down, right? You got this cap here, right? This cap here. You have 0.1. Right? And now in the Python, you also have else here. And remember that for the else also, you have to put the colon also, right? And you see, everything between the if and else here, make sure that you have to use the correct indentation. Right? So basically, when you work with the Visual Studio Code here, it automatically do it for you. You don't have to do it here, right? So see, whenever I work with the else here, right? So whenever I work with the else here, so you can see what happened here. When I work here, I hit the enter, it automatically indent to one level here. Right? I don't have to do it. So that's why I really like working with the Visual Code or any idle program here. Else, that means this count here, right? This count here. You put it 0, right? And of course, you print it here at the end, right? Your discount is discount. Okay, that's a very simple program here. So you see, the structure of this program here, the structure of this program, right? You get it from the user. You store it into the variable name here, customer age. H here, right? And now we got it. You check the condition here. If customer H greater than or equal 65, you lose this one. If not, you lose this one here. Right? So basically, you have the selection here, right? Customer H here. I check it greater than or equal 65 or not. Right? If yes, you have discount here. 0.1. Right? If no, this one yes. If no, you lose the other one. Right? Discount here. 0. Right? And after that, you see, you just print it out here. Right? So remember that whenever you do the selection, whatever it is, you only able to execute one branch only. Never ever both branches. Right? You see, you can either greater than or equal 65 or not. Only one condition. Sorry, one possible outcome only. Right? Okay. So now for this one here. For this one, right? You can run the program. Right? You can run the program here. You can save it first. Right? That's here. You run the program. So I got it from the program here. Think about if I put a 50 here, right? So see the 50 here, right? You check the condition here, not correct, right? So what happened? If not correct, it go to the else, right? So if it go to the else, that means I have this count here 0, and I print it out, so it out here is 0. It's 0 here, right? And again, if I run it again, right? If I run it again, I had this one. I have the 70 here. So 70 here. You check. This one is correct, right? That's why I have discount 0.1 and I print it out here. Draw discount here is 0.1. Okay, makes sense. This one is very, very simple program. You guys got it? Okay. So I strongly recommend you open with the Python and work this one with the Python. Okay. Now come back to the problem here. Come back to the problem. When you work with the combination of the AND decision here, right? So in this program, right, you are only able to join the army when you are greater than or equal 18 here, and your weight here is greater than 140, right? So basically here, in the Python, right? In the Python here, you can work with the AND logic by netting decision, right? So see, I got the H here. I check here if H greater than 18 or not, and after that I got the weight here, and I check if the weight greater than 140 or not, right? Okay, or I can check the weight first or the H letter here. But remember that in the case of the netted logic here, netted AND logic here, you should check the program, the condition that likely to be true first. Okay, to make it more efficient here. So in the case, if we work with the netted AND decision here, you see this one here, you totally netted into the other one, right? And this one here, you totally netted into the other one here, right? That's why they call it netted here, nested, right? Netted decision here. So basically, for these two programs, they provide the same output. So whatever, if you only able to join the army when you are greater than or equal 18 years old, and your weight here greater than or equal 140 here. They both deliver the same output, but the way it executes is not the same, right? Okay. So I mentioned about in the case of the conditional and operator, right? So we have you have two or more questions in the single comparison here, and each Boolean expression must be true or entire expression to be evaluated to be true here, right? So you know about the true table already about the end here, right? Now think about when you work with a combined several Boolean expression that have a true or false here, meaning into the single expression using the AND operator, right? And in the AND operator here, both expression to be true in order to entire expression to be true here, right? So think about this one here. If I want to go to the movie and I have enough money, then I will go to the movie here, right? So what is it? For sure, I will go to the movie here, right? I will go to the movie here only when I want it and I have enough money, right? Both of the condition. If I don't want it, for sure I don't want to go to money here. Or if I want it, but I do not have enough money, I cannot go to the movie here, right? So basically the output of this one for the AND logic, in order to be true, both of the condition must be true here, Right? That is the logic of AND here. So you see in this program here, right? For these two programs here, they are the same. They are the same. They deliver the same here, right? So for this one here, now for this one here, you could combine them together into a single line. Right? So instead of put in the netting here, see this one here, right? You put it in the netting in the other one here. You can use it with the AND here. You can combine them both the condition together. But remember the way computer execute here exactly the same as this one. It have to check this one first, right? It have to check this one here first here. If this one not, you see, if this one not, for sure, it will skip the second one here. And if this one not here, it don't have to check this one. Okay? Because you know that the AND logic, the output is only correct when both of the inputs are correct, right? So see, if this one not, you do not have to check the second condition. That's the way computer execute with the AND logic. This one also, right? See, if he's 16 here, it's not less than, you skip everything here. You don't have to do it. Okay? That's the way the computer execute when it works the AND logic here. So see, when it works this one here with the Python, it's exactly the same as this one. But see, when you put the AND here, you net them together here. Okay? Now, in order to work with the AND selection here, right? The second decision here must be made entirely within the first decision. That's why they call it a method. Right? They call it a method. That means you have to put it entirely within the first decision here. And the mode programming language, logical AND, is binary operator. Right? It requires a complete Boolean expression in both sides here. Right? So you avoid some common mistake error in the and selection here. Now, if you look into my slide here, if you look in my program here, right? What's wrong with my program? If you look on this one, what's wrong with my program? For this one.
The if wait statement isn't nested in.
Yeah, they are netted, not netted there. Right? So we see what happened here. Now think about this one here. If this guy here, right? If this guy here, 20 here, right? And 20 years old, right? And he's only 100 power only, right? 100 power only. So what happened here? I check the condition here, right? Now 20 here, right? 20 here, correct. You are eligible to join. You do not have to check for this one. Right? You do not have to check this one here. For sure, you have this one here. Right? So that's why here, when you work with the AND selection here, make sure that you have to net them into each other. Right? You have to net them into each other here. Now, if you do it in the way you work one by one here, it's totally wrong. Right? In that case here, if he's 20, he able to join. I mean, even that he only 100 pounds. Okay, so remember here, the common mistake in the case you work the AND decision here, you have to make sure that you have to put the AND decision here totally entirely within the first decision. If you have the second decision, right, you have to put it totally inside the second one here. So that's why here, right, in the case in this program here, in this program here, if you work with the draw IO here, right, you have to make sure that you have to put the decision, the second decision totally inside the first decision here, right? So think about this one here. I have the check here, if yes here. H greater than or equal 18 or not, right? And now if not here, I do the other action here, right? So if not, I have to work with the other action here, right? I work with decision here. Check with the second decision here, right? I check with the second decision. Now I have wait here. Greater than or equal 180 or 140 or not. Okay. So now you see, if you look, if I work with the project here, right? So if h greater than 18, then I go to check the weight here. Right? If not, for sure, right? If not for sure here, I just put it here, right? Sorry. Sorry. You are not answering. for this one, right? For sure, if he's whatever he is less than 18 here, we have no way to join it. Sorry. Where am I? It's not, right? So I have no here. Right? And I have yes here. Okay, and now you see, even that yes here, I have to check the second condition also. I have to check for the second condition also, right? And only when he greater than here, right? It is yes here. Right? If he yes here, you got it. Able to join that. If not, what happened? Again, right? If not, what happened here? Again, you are not able to join. Right? This one output. Contract. You are able to join. Yeah. Okay. Now, connect them together because every decision here you only have one input only, right? Sorry, one output only. One output and one input. One output here and one input. It's one of them, right? You have to connect them together into the structure here. And you go to the end program. Yeah, you learned about structure already, right? So you know that for any decision here, for any module, right, you only have one input and one output. Right, so see, there's this program here. For program here, that is input, that is output. For this structure also, this is input and this is output. Right? To make sure that you make a structure here. So we see what happened here. This one here, you totally netted into the other one. Right? That is the second condition here. Second condition. And this is the first condition here. And you see, I put the second condition here totally inside the other one. That's why the process I call the negative, right? Okay. Make sure you follow the structure when you work the flowchart for this one. Okay, so that is the case of n, right? Sometimes you work the all and so, right? Sometimes you work with the all here. And you know that in the case of the odd decision, right? You know that in the case of odd decision here. The output is true when at least one of them is true, right? At least one of them is true here. So the odd decision here take action when one or the other of the two conditions is true, right? Are you free for dinner Friday or Saturday? That means Friday, either Friday or Saturday work, right? It doesn't matter, Friday or Saturday, either of them work here. Or both of them is okay, right? Both of them is okay for that one. So think about this one here, right? So in the case of the odd decision here, right? You must ask either the question first, it doesn't matter. Think about this one, right? Think about my program here. Think about my program here, right? To get the premium rate here, right? To get the premium rate, whenever you get the premium rate, whenever you make more than 100 call or the message send greater than 500 here. Right, so now I'm asking you the question here. So if I make 50 call here and I send it out for 400 message here. So what I think, do I get the premium rate or not? Can I get it? I make the 150 call here, right? 50 call and 400 message. Do I get premium rate or not? No, right? Because both of the condition here true. Not sorry, both the condition here not correct. Right? But either one of them correct. I got the frequency. I think about if I made for the 150 here, and even that I only send for the 200 here, I got it because I made it greater than 1. And remember, this is all decision. All decision, you know that for the truth table here, right? For the truth table here, you have this one here, call here, right? Call here greater than 100. Message here greater than 500, and right here premium. So see, this one true, this one true. You have true here, right? This one true. You have 4. You have true here. This one 4. This one true. You have true here, and this one 4. This one 4. You have 4. Right? So see, the output here always true when at least one of them true. Right? That's why if I make it more than 150 here, I do not have to check for this one. I do not have to check for this one anymore, right? Or if I send it for the 600 message here, for sure, I got premium rate. I do not have to check for the core anymore, right? So basically, again, in the case you work with all logic here. Now, you ask the questions that more likely to be true. You know that it's opposite with the AND logic. In the AND logic here, you ask the questions that less likely to be true. So when the case of the AND logic here, if less likely to be true, you check if the condition not true, you skip the second condition. Right? But in the case of the OR decision here, right, you just raise the question here. If the first question that is more likely to be true, you do not have to check for the second condition. Right? Because it's OR logic. Right? Okay? So about it here, right? So in the case of the conditional or operator here, you can ask 2 or more questions in the single comparison here, and only one Boolean expression in an OR decision must be true to produce the result of true here, right? So that's why here you raise the question that most likely to be true first. Okay, so again, in the case of the common error in the OR decision here, right? The second question must be self-contained structure with the one entry, one exit point of view. So remember that case when you work with the flow chart also, you have to put it with structure, right? That you see. I show you how to work with structure here. You have also remember that for any structure here, you only have one exit, one input and one exit here. This one, right? One exit and one input. This one also, one input and one exit here. Okay, so we do the same with OR logic. You do the same with OR logic also. You do the same with OR logic, right? So remember that you have to work with structure logic here. Sorry. Now this one also, you can see for this one here. We mentioned that this one is not logic, and you know why? You know why it's not logic? I mentioned it already. Right? Why? It's because it interleaving here, right? Because you see that when you work with any decision here, you can either work on this branch or this branch only. You cannot do it at the same time, right? So see, you cannot jump from here to here. If you want, you have to break it down into 2 separate structures. Okay. Okay. Now some of the common mistake with the OR here. Now think about this one. Now think about this one here, right? So okay, for this one here. In order to do this, right, you can use an OR operator and the logic behind it here. So see, you can use this combination here, right? Is a core mate greater than core here? That means 100 here, 100 here, and 500 here. You can combine them into the single lines. But remember, the way it works exactly the same with the network here, right? You check the condition here first, and now you check the second condition here. But you see, in the case here, if you check the condition here, if yes, for sure, you got premium. You don't have to check this one, right? That is the case you work the OR here. If not, again, you have to check for the second condition. Okay. Now, in the case you work the OR here, you have to pay attention in the case. Right? So think about this one here, right? Think about this one here. Now, this guy here, right? This guy here, he got the discount rate, right? He got the discount rate whenever he greater than 65, right? Whenever he greater than 65, or whenever he less than 13 here. So whenever, whoever greater than 65 or less than or equal 13, he got the discount rate here, right? He has got discount rate, discount price here, 60. Now, if you look on this one here, what do you think? What go wrong with this program? If you look on the condition here, if age less than 13 and age greater than 54, you got the discount price 60.
It's an and statement.
Yes. The key here is and. You know that what happened here? That means he have the less than 13 and he have the greater than 65. No one. No one at the same time less than 13 and no one at the same time greater than 65. Right? So basically you have to put all here. Right? So you have to pay attention in the case you work with the combination of the logic here, and or. You have to make the right decision with and or here. You cannot use and here because no one at the same time less than 13 and at the same time greater than 65 here. Right? You can use all here, either less than 13 or either greater than 65. Work here. Okay? Well, that's one. So I think you guys can take a short break for 5 minutes and we come back. Okay, so for this problem here, the same process with this one here, right? If you look on this one also, the same error here. Right? So see, if the patrol here greater than what means here, right? You have the 20 or less than here, then you got the full price. So now you see, if you look on this one here, if you look at the condition for this one, if you look at the condition here for this one, what's wrong with this condition here? What do you think? Tell me. If greater than 12 here or less than 65 here, you got the full price, right? You got the full price here. So what's wrong with this program? What's wrong with this program here? What's wrong with this statement here?
Greater than or equal to, right? Or less than or equal to instead of just less than or greater than.
That would be above, like you could be like 70, but that would still be above the minimum age. So you would still get full price.
Say again.
So like you could, if you're 60, like above the max age, you would be above the minimum age. So you would get the full price. Because there's no minimum age, even though you're supposed to get the discount price.
Yes, right. Now here, to make it simple, you can draw the number line here. Right? You have everything from 0, you have the 13, and you have the 65, right? You have the 12 here, right? 12 and 65, and more than that. Now see, if greater than 12, what is it? Everything greater than 12, right? Everything greater than 12. Now you see, all here, less than 65 here, so everything less than 65. So basically you see, everyone, right? That one because it is all here. That means you see everything greater than 12 here, or less than 65 here. That means everyone. So see, everyone here you have to got the full price here, right? So the all here is not correct. The all here is not correct. You have to put and. You have to put and here. You see number line here, right? You see number line here 0 here. You have number 12 here. You have the 65 here and more than 65 here. See, if greater than here, right? Greater than here, greater than 65 here, and less than 65 here. Sorry, greater than 12 here and less than 65 here. What they have in common? They have in common here, right? So we have to use the AND logic here, not all logic. You can see, I don't know if you learned about the Venn diagram already. Right? You have a Venn diagram, you see, but this one here, you have greater than 12, right? This one here, you have less than 65. And the common between greater than 12 and 65 here, it is the AND logic here. Right? That's AND logic. So you see, if you put all here, that means everything. Actually, this one you have to correct with the AND logic here. That means you can greater than number 12 and less than 65. You got it. Make sense? Okay. So remember that in the case of the combination of the compound logic, the and or is somehow quite confusing. That's why you have to pay attention to make sure that you put the correct one here, right? So instead of or, you have to put and here. Make sense? Okay. And sometimes you work with a not operator also. You know that the not operator, that means everything about the reverse process also, right? So think about in the case, if this one here, if not age less than 18 here, can register to board, right? Because in that case, he greater than or equal 18 here. Okay. Now, in the case, if you have you have to careful in the case of create the trivial expression here, right? So think about this one here. If not employee department number 1 or not employee department number 2, then the output employee is not department of number 1 and 2 here, right? So what is wrong with this one? What is wrong with this one here? What do you think? What's wrong with this one? The first one. What's wrong? If not employee department number 1 or not employee department number 2, what's wrong? Now see. Now please see about this one here. Right? Now tell me. Like, let me give you the one here. If the one here, if the employee department number 2 here, you can see what happened. Right? Now this one. Right? You see what happened here? Employee department number 1 here. This one 4, right? This one 4. But you see, not of the 4, you have to choose here. Right? And see, not of employee department number 2 here, employee department 2, not of them, you have 4. But you see, you have all here. 2 and 4, you have 2. Right? That's why this one is not correct. Right? Okay, so in that case, you have see, you have to put it totally here in parentheses. Right? If not employee number 1 or employee number 2, then after that, employee is not in department number 1. So, okay. Okay, now the other concept when you learn about the range here. Sorry, if when you learn about the selection here, you learn about the selection here. That is when you work the range. Right? In the range here, think about in the case of range. Now, let me give you the example in the case of range here. Right? So you have the program here. You have to get the item order from customer here, and you have to make decision. If he order everything less than number 10 or equal number 10, you have 0% discount. Right? If everything is range from the 11 to 24 here, you have the 10%. It's range from 25 to 50 here, you have the 50%, and greater than or equal 51, you have the 10%. That is the range. And the reason the range here, you can see, if you draw the number line here, right? You see, less than or equal number 10, you have 0%. Right? And from number 10 to 25 here, right? Less than that, right? You have the 10% here. And from 25 here to 50 here, right? You have the 15%. And more than that, you have the 20%. That's the range. That's the range here. Now, in the case of the range here, how we work with this one? How we work the range here? Now, you can work in the long way here. You see, I make a decision here. If the item order less than number 10 or equal number 10, I can put here. No discount here, right? If number item greater than 10 and less than or equal number 24, you have the 10% discount here, and so on. Of course, I can do this one in the long way here. In the long way. But what do you think? If you look on this program here, now tell me, what is the drawback of this one? What? Why not? What do you mean the long way? What do you mean the long way?
Gotta go through each.
Yeah, right. You have to go all of the condition here. I think about if I put number 5 here, right? So for sure, I got no discount here. But again, I have to check this one again. I have to check this one again, and I have to check this one again. So even that the output is correct, I print it out here. No discount here because this one is one condition true, right? This one here, you check, you skip it. You check, you skip it. You check, you skip it here. The output is correct. But what happened here? My program here, you have to execute all of the condition here. So this is a simple program. You don't see any different between the way it execute. But you think about in the computer, you have the complicated program here. You can see the difference in the way it execute. Right? So this is not good program because you see whatever it is, whenever you enter any item number here, you have to check for the first one, you have to check for the second one, check the fourth one, and the third one and the fourth one here. It's not good. It's not good, right? So basically, in the case you work with the range here, remember that in the case you work with the range here. In the case you work with the range here. Remember, you work the netted selection. You have to put it in the netted together, right? So now this one here, I work with the netted here. You see in the case I work with netted here, right? You have to check all the possible condition here. It's really slow down the processing time here, right? So now in the case I work with the long way here. You see, I work with the flow chart here. You see, whatever I did, whenever I have to go for the first one, I have to go to the second one, I have to go to the third one, and I have to go to the fourth one here. It really slows down processing time of the computer, right? So basically, whenever you work the range, you work with the netted decision here. You have to work in netted decision here, right? So think about this one here. Now, you can see what happened with my netted decision here, right? I put this one inside the other one. And I put this one here inside the other one here. That's why they call it a netted decision here. Right. So now if you look in my decision here, you can look in my program here. You can see what happened. This one I work with the flow chart here. See what happened here. If I enter the number order number 5. Now you see, if I enter the number 5 here, you see what happened with my program. What happened with my program here? See, if I enter the number order number 5, what happened? Now tell me what happened with my program. If I enter the item number 5 here, what happened with my program?
You get the discount 1.
You go on this one, yes, right? This one, yes. And you go to discount here, number 1, and that you exit it. You don't have to check for this one. You don't have to check for this one, and so on. That is a huge benefit when you compare to the long way here, right? That's why remember that whenever you work the range here, whenever you work the range, you work with the netted selection here, right? You put it one into the other one here, okay? So you see, in the case you work with the flow chart here, you have to remember every structure here, you only have one input and one output only. You see, for this one here, that is input, that is output here, right? For the second one here, this is input, and this one is output here, right? And the third one, this is input, and this one is output here. Remember that whenever you do net, you have to put it totally inside this other, right? Think about this one here. When you work with pseudocode here, when you work with pseudocode, that is the first one, right? Now the second one, that is the second one. And you see, that is the third one. You put it in each other here, right? And you see, they work with the alignment here. They work with the indentation here. So it's very structured to see how they are netted together. You see, for this one here, that is the most inner one, right? That is the most sorry, not this one. Yeah, you see, if and else here. That is the most inner one, right? That is the most inner one. You put it in the another one here. You put it in another one here, and again, you put it in the outer selection here. That's why they call it the netted selection here. Okay, so in the case you work with the netted decision here, you can work with the flowchart, or you can work with the pseudocode here. And if you work with the Python, that is the structure here. Right? You see, if here less than range of number 1, number 10, you have the 0 discount here, and so on and so on. Okay, we put it inside each other here. That is structure. We work with the multiple selection here. Now, some of the common error here. Some of the common error when you using the range check here, right? Avoid dead or unreachable party. So what is it? That means you don't check for the values that can never occur and require some prior knowledge of the data here. Right? So now see, if I go to my structure here, see for this one here. Now, they call this one the dead one here. Why is the dead one? Because the program never ever go on this one. Never ever go on this one. I see you have the range of 0 here, right? You have the 10 here, you have 25 here, you have a 50 here and more than 50 here. Now see what happened here. If I got everything less than number 5, I go on this one. Right? If I have everything from the number 10, right? If I have everything less than number 10, I go on this one. If everything in the 10 to 25, I go on this one. Right? If everything from the 25 to 50 here, I go on this one. Right? If not, I go on this one. You see? Never ever check this one. And that's why they call the dead end. Dead end, that means in the program. The dead end here in the program that you do not check for value that never ever occur here. So we see is this one here? No, not at all. Right? Not at all. Never ever happen here. So don't use it. Don't use this one here. So how we correct it? You see this one here. Right? We put this one here. You see less than 10 here. From the 10 to 25 here, right? From the 25 to 50 here and greater than 50 here. This one way better than the other one, right? Because the other one here, you have the dead end here. You have the dead end here, right? So basically, you see, or this one here. No, sorry, this one here. You don't have to check this one anymore, because for sure here, if no, that means already greater than here. Why do we have to check it? Actually, you just connect it into this branching. You do not have to check it here again. Make sense? Okay, that's the first thing. Right? So avoid some mistake here. Avoid some mistake in the code you work through here. Avoid that or unreachable path. What's that? Do not check for values that never ever occur here and require some prior knowledge of the data here. Now, also, you only check, right? Never ask a question that is only one possible outcome. You know for sure it only have one outcome. Why you have to check? This one, Jose, is this one here, right? You see, for sure. If not this one, if not this one, if it's not this one, for sure, it is greater than 50 here. So why you have to check here again? You don't have to check it because for sure it only have one outcome here. Make sense? Okay, you only have one outcome here. That's why never ask a question that only one possible outcome. And the fourth one here, avoid testing same range limit multiple times. Now we see for this one here. Here, was it program here, right? Was it program here? Now we see for this program here, right? You check it here. If the item order less than range number 1 here, you go on this one. Again, if the item order greater than number 1 and less than number 2 here, now see, you do not have to check this one, right? Because see, no here for sure it's greater than here. So why do you have to check it here again? Why do you have to check it here again? Right? So avoid it because you know that whenever you put the condition, the computer has slowed down to process that condition here. Make sense? So yes, never ever use the multiple question for the same range. Right? See, for this one here. If I enter anything less than number 10, I will work with this one here. Right? If I enter number 15 here, sorry, 15 here, for sure, it's no here, right? No here, that means greater than here. I don't have to check it here again. Make sense? Okay. Okay. So now sometimes you have to understanding the order of operation, right? Order of operation here. So when you combine AND and OR operation hit interaction here, you know that the AND has a higher priority than the OR here. Right? The AND has the high priority here. So think about this one here. If score number 1 greater than minimum score and score number 2 greater than minimum minimum score and score number 3 here greater than minimum score, then you have the pass here and now you have failure. That means, what does it mean? That means both of the score greater than minimum here, right? Because you use the AND here. But what happens if you use the OR here? That means only one of them greater than you are okay with that one. You pass this one here, right? So make sure that you understand the concept of AND and OR here. And remember that the AND has the higher priority than the OR here. Okay. So whenever you have AND and OR operator, they are combined in the same statement here. The AND operator are evaluated. I think about this one here. If H less than 12 or H less than greater than 65, and rating is G here. So what does it mean? That means you have to execute the ratings G first, right? And later on, you work with this one here. Now, if you work on this one here, you see what happened. Actually, you group them together first here, right? Because N here have the higher priority, right? So in order to correct it here, actually you have to put them into the parentheses here, right? That's the second one. Make sense? Because you have to understand the concept of the order of operation. First one is not. So actually, the first one is the parenthesis, right? Everything is inside the parenthesis. You do it first. The second one not. The third one and the fourth one all. Right? So in order to translate it correctly, you have to put the parenthesis. Is this one? Either he is less than 12 or he greater than 65, and the rating G is okay. Make sense? Okay. Okay, so when you mixing AND and OR operator to make your logic more complicated, and somehow if you want to avoid it, you can use the netted. You can use the netted here. You break it down into the netted selection and you put it here. Right? Think about this one here. Right? Think about in the case of this program here, right? I can put it in the netted here. I can put it in the netted here, right? So I check it here. If the rating is G or not, if yes, I check if he is greater than or less than 12 or not here, and so on here. And I check it with a greater than 65 or not. Right? Of course, I can put a combination here, right? I can check here. H less than or equal 12 or H greater than or equal 65. I can put them in one condition here, it's okay. But if you think it's more complicated, you can break it down into the netted selection. So it's very easy for you to follow with the structure. Okay, and somehow and work with the selection home. So selection here, you have the case structure also, right? Case structure also, right? In the case structure here, it is a specialized selection structure, and it used when there are several distinct possible value for a single variable here, and each of the value require a different subsequent action here. Think about this one here, right? So we have for this one here, if you work with the netted selection here, you break it down the netted, and so on here. But if you work the case here, right? You see, you have the condition here to check. If 1, you go on this option. If 2, you go on this option. 3, you go with this option here, and otherwise you go with this option. That is the case, right? The case that means you have the multiple options to do it in the value here. Basically, the structure is quite the same when you put the net. But if you look on the presentation here, it's very easy for you to see what's going on with the selection. Okay, so I think that something about the slide here, I just wanted to show you. It's quite simple for this program here. I saw for this module here. But anyway, I have some of the activity here for you to do it today. So you can go over to the module number 4, number 5. And is that I have one activity here for today. I have one activity, and you can download the instruction here, and you can work on the activity properly. So I expect that you will do it. So think about it. You have to write the program here in pseudocode, and after that you do it in the flowchart to determine if the customer get premium rate or not. Right? So he get premium rate when he make more than 200 call, and the total call duration is greater than 1,000 minutes here. Right? So now, in order to do that one here, in order to do any program here, the first step you have to deeply understand the problem here. Right? So in this program, I'm asking you to write the program in pseudocode and flowchart to determine if a customer get premium rate or not. And the customer get premium rate when he make more than 200 call, and the total call duration here, it is more than 1,000 minutes. Now, if you look on this program here, the first step, I just want to the question here. What do you think? What are the input for this program? Any program, the first step, right, you have identified here the problem, and also we have to find out what are the input here. So what if you look on this program, what do you think? What are the input for this program? What are the input for this program? Now, if you look at the
minutes.
Sorry, say again.
The total calls and the total minutes.
Now, you need to get the how many call, right? and need to get how many duration also, right? What else? Name also, right? You see the name here. I execute it for the first time. If I enter the David, I print out the name David here, right? So basically for this program here, you have 3 input. You need to get the name from customer, right? You need to get how many call from the customer, and you need to get the duration, call duration from customer, right? And after that, what else? You make decision here, right? You make decision here. If he's able to get the premium rate here, in the case if he more than 200 call and the total call duration here greater than 1,000. So remember this one here. This one here. You have and here. Remember this one's and, right? This one and here. Okay. So now you do it in the pseudocode and the flowchart, both of them, right? And you see, if I execute for the first time here, execute for the second time here, and execute for the third time here. You see, if he only have 100 here, right? For sure, right? Normal rate, right? If he have the 250 here and 800 here, he got the normal rate because you see, less than 1,000 here, right? Less than 1. Okay, so now do it in the pseudocode and the flowchart also. So remember, you need the 3 input, right? So after that, you make decision here with the AND logic here, with AND logic. If greater than 200